Good afternoon to all our respected dignitaries, esteemed resource persons, faculty member, research scholar, and dear participants. I hope everyone found the first technical session of day 2 to be enriching and insightful. It was all about energy audit. We have learned so many things, so many details about energy audit in the last session. Now we are moving on the second technical session of today's faculty development program, which promises to be equally informative and thought-provoking. The topic for this session is renewable energy system, a subject that lies at the heart of sustainable development and global transition towards clean and green energy. As the demand for environmentally friendly energy solutions continues to grow, understanding renewable energy systems has become essential for researchers, academicians, engineers, and policymakers alike. It is indeed my privilege and honor to introduce our distinguished resource person for this session, Dr. Chanchal Loha, Scientist F and Head of the Energy Research and Technology Group, ERTG, CSIR-CMERI. Dr. Loha completed his bachelor's degree in mechanical engineering from IIST, Sipur, MTech in thermal engineering from IIT, BHU, and earned his PhD from Durgapur University, where his research focused on biomass gasification. With nearly 2 decades of dedicated research and innovation, Dr. Loha has established himself as a leading expert in renewable energy, biomass and waste-to-energy technologies, hydrogen energy, low GWP refrigeration system, solar cooking technologies, carbon capture and clean energy solution. He has an impressive research portfolio comprising more than 80 scholarly publications, including 15 journal articles, 25 conference papers, and 7 book chapters. Ladies and gentlemen, please join me in giving a warm round of applause as we welcome our esteemed speaker, Dr. Chanchal Loha. To honor our distinguished guest, I now respectfully invite our respected Principal, Professor Dr. Urijit Kumar Banerjee, to kindly felicitate Dr. Chanchal Loha with a bouquet as a token of our heartfelt gratitude and appreciation. Dr. Loha, we are truly honored by your gracious presence. We are confident that your vast experience and expertise will greatly enrich all the participants and inspire meaningful discussions on renewable energy technologies. Without taking any more of your valuable time, I respectfully invite Dr. Chanchal Loha to deliver his expert lecture on renewable energy system. Sir, please.
So, good afternoon all. So, thank you for a nice introduction. So, I am Dr. Chanchal Loha, as it is introduced by faculty. So, I am currently working as the scientist staff and head of Energy Research and Technology Group of CSIR Central Mechanical Engineering Research Institute. So, do you know about CSIR? CSIR is Council of Scientific and Industrial Research. So, our headquarters is at Delhi, and we have total 38 laboratories at different disciplines and located throughout India. So, CMERI, that is Central Mechanical Engineering Research Institute, it is located at Durgapur and is the only research lab focused on mechanical and allied areas. This is the only national research activity laboratory. Similarly, we have CSIR laboratories at Kolkata, that is CGCRI, Central Ceramic and Glass Research, and then IICT. So there are 3 laboratories in West Bengal. Then other laboratory you might have heard about the name, that is NCL Pune, National Chemical Laboratory, National Aeronautical Laboratory, and then NPL, then NMI, Jamshedpur, Tulpar, Dhanbad. So total 38 laboratories, and then each laboratory also they have their extension center. Like CMERI has one extension center at Ludhiana. Okay. So we have one extension center at Ludhiana. So just I will first briefly talk about the research activities or particularly the work which we do at CMERI. CMERI particularly known for the development of tractor technologies. So we gave the first indigenous tractor to India, that is Swaraj tractor. Next.
Hello.
Okay. So our journey started from the development of tractor. So we developed first indigenous tractor, that is Swaraj tractor, then Sonalika, then KC Shakti. And now actually our CMERI is having different departments, like we have robotics and automation department, we have energy department, farm machinery, electric mobility and manufacturing, and other departments. So I belong to energy research and technology. So I belongs to energy research and technology group, where we mostly work on the renewable energy, or you can say low carbon energy. So today I will talk about the renewable energy systems. So basically I will cover some introductions, like what are the different renewable energy systems, and what are their advantages, disadvantages, and what is the current energy scenario worldwide as well as in India. With respect to world, what is our scenario and what is our target. And then I will also talk about some of our research activities which we are carrying out in our laboratories. So first of all, what is renewable energy? As you understand, renewable means the energy or energy source which can be renewed by our natural process, natural ecological process, that is renewable energy. Similarly, so the energy which is not renewable, which will be depleted, for example fossil fuel. So presently we have coal available, but this is limited. So as we consume this coal, if we consume it faster, it will be depleted faster. But if we use it in a very intelligent way, we reduce the consumption of coal, then maybe we will be able to continue another 50 years or 100 years. So let us look at the energy scenario, the global energy scenario. So if you see that still most of the energy is coming from the fossil fuel, that is oil, coal and natural gas. These three continues, these three if you add, it will be almost 80%, 81%. So in the world itself still we are mostly dependent on the fossil fuels. And renewable is another 15% and nuclear is 4%. So total is 100%. So this is the world energy scenario, though it varies country to country. The developed countries, they have increased their renewable energy contribution a lot, but there are countries like particularly the developing countries or underdeveloped countries, there lots of fossil fuels are used in it. Now if we look at the Indian scenario, yeah, so this is the Indian scenario. This is the scenario, it was in 2011. So there total energy demand was 173.6 gigawatt, whereas the contribution of coal was 57%, gas 10%, nuclear 2%, hydro 19% and renewable is 12%. Though hydro comes under renewable, but still it is always given separately than renewable. So total these two will be the renewable. And if you look at the scenario in 2025, how it is changes, our demand has increased more than two times, whereas our contribution to the coal remains still 48%, which is really a concern. Still 48.27% of our total energy comes from coal. And then we have biopower 2.43%, wind 10.47%. Then solar has increased a lot, 19.84%. Then this small hydro 1.12, oil and gas it is 5.64%, and nuclear is 1.81, and this is the hydro 10.41%. So this is the main concern. We have to convert from this non-renewable to the renewable. So this is the only future, because as I told, like coal reserve is limited. So if we increase our consumption, like there it was 57%, but the amount if you calculate with respect to this it was less. But now it is, though the percentage is less, but the total amount if you calculate with respect to this, the consumption is increased. So these are the some of major coal-fired power plant. So like the biggest coal-fired power plant is located at Gujarat, that is in Mundra. Its capacity is 4,620 megawatt. Then another is Ultra Mega Power Station, that is also in Mundra, that is 4,000 megawatt. Then Namagundam is owned by NTPC. Then Mejia, we have Mejia Thermal Power Station, the capacity is 2,340. Chandrapura, Singarali, Korba. These are the major power plants. Besides this, there are also 17 thermal power plants by NTPC. The total capacity is around 33,015 megawatt. Plus there are 6 joint ventures, that is NTPC plus some other companies joint venture, and that also constitute 4,034 megawatts. Now if we look at the coal, Indian coal, like our Indian coal, the main concern is the quality. The quality of our coal which we have is far inferior than the coal which is available internationally. So this is the Indian coal quality and this is the average international coal quality. So major concern is that if you see that HHV, that is higher heating value, that is calorific value. So our Indian coal is having the calorific value of 3,800 kilocalorie per kg, whereas the international coal is having much higher. It is more than 1.5 times. So it is 6,000 kilocalorie per kg. That means if you want to produce same amount of energy, you need more Indian coal than the international coal. And the another main concern is the average ash content. Average ash content is 40%. So in Indian coal, 40% is the ash. That you can understand that how much pollution it will do when it will be combusted. So this is a major concern. And what are the adverse effects of coal? So these are the different adverse effects if you burn the coal. can see its black smoke comes out which contains CO2. So coal-fired power plant have the highest carbon intensity among all the fossil fuels. Then if you go to the coal mines, this coal mining rips off landscape, pollute the bodies, waterways and cause air pollution. So this is the situation of the coal mine. If you go to any coal mine, there are a lot of coal mine in near Raniganj area. So you can see that lots of coals, this unused coal is heaped up. So which is creating water pollution as well as air pollution. Then this coal mines, how it is done? It is a destructive method. So blasting is done. So this is also affecting our nature. So if you see basically also this coal contains the mercury. This is another person. This comes to our marine life and it is affecting our fisheries. So average if you can try to understand that if you burn 1 ton of black coal and you get 4 tons of CO2. So how much polluted coal is, you can understand from this. And our coal is basically bituminous or subbituminous. So if you compare this, you see that anthracite coal releases 67% more CO2 than the methane, and brown coal releases 130% more CO2 emission than the methane. So we have basically brown coal or sometimes like low bituminous type of coal. So another is the in thermal power plant, along with the coal it also contains sulfur, so which emits SOx, and due to high temperature this nitrogen gases they produces NOx. So SOx, NOx, then GHG emissions, SMOX, these are the another issues. But what to do, because the demand for energy is increasing globally. So if you look at this scenario, this is the global growth for 2012 to 2035. So this is the growth. So non-OECD countries, that means the countries which are not a part of this Organization for Economic and Cooperation and Development. Basically the main developed countries are the part, we are not the part, like we comes under this. India, China, we comes under this. So basically this Asia and South America, this part, the major growth will take place in this area. Whereas if you see that OECD's countries, the developed countries, growth will remain almost 4%, not very much. And also Eurasia will 5%, Latin America 8%, Africa 8%, and Middle East 10%. And if we look at the primary energy demand by 2035, so this is the primary energy demand in terms of oil equivalent. This is million tons of oil equivalent. If we see that most of the energy demand will be from the China, and India is also not lagging behind. So like China will be requiring 4060 million tons of oil equivalent. Then India will be will require. This is India. Okay, sorry. India will require 1540, and total Europe will be requiring only 1710, and United States will also demand a major contributor, that is the consumer, that is the 2240. So these are the major areas where the development and the energy demand will increase. And this is a scenario for the demand of electricity, how it will grow in India. So it is given with respect to two parameters. One is the peak demand, one is the capacity requirement. So you can see this is also increasing in a straight way. So we cannot stop our demand. It will increase. As we will develop, our demand of energy will also increase. And this is the increase, that was the power sector, and this is the increase in the oil dependency, that means in transport sector. How it will increase, we can see that from 2015 it will increase, then 2045, after that it will be stable. And this is the contribution from petrol and diesel. So diesel will remain almost constant after 2045, and the petrol demand will slowly it will decrease. So basically, due to the use of this fossil fuel, our global temperature is increasing. That is the main concern. So if you see the projections, so how our temperature, global average temperature is increasing, or it will be increases, means it will increase in the future. So if we pay attention and immediately convert it to the renewable energy, then we will follow this path. And accordingly, based on the renewable conversion, these are the projection. If we don't pay attention, our temperature increase will be like that. So average temperature increase. So basically, as I told, like our global average temperature is increasing, and we are already facing 1 degree warmer than the average global temperature, and we are expecting that will be very soon will reach to 1.5 degree. So this is the climate clock. Any one of you know the meaning of this? There is some 2 years, 362 days, and some time is written. So do you know what is the meaning of this climate clock? If you go to any offices, any big offices, or any environment related offices, or even in big cities in any entire world, if you go, you will see this climate clock is installed everywhere. So basically, this climate clock is showing that we'll reach 1.5 degree limit by another 2 years, 362 days, and this minutes. So our objective is to delay that. So if we increase the use of renewable energy, this will increase. Instead of 2 years, it will be 3 years, 4 years, 5 years, 10 years. So that is our count actually. We are keeping it in front, and we are targeting it how we can delay it. And if we don't pay attention, whatever the way we are going on, if it goes, then we'll reach this by 2 years, 362 days. So it is changing every day based on the map, entire world map, how the pollution are happening in entire world through the satellite data. They are getting the data, and they are simulating from there, they are calculating, and it is installed at the Geneva, Switzerland. So it is essential to convert it from the existing fossil fuel based energy to renewable energy. There is no other options. So why renewable energy? Like I already discussed, like what are the major challenges with the fossil fuel based energy? One is climate change, then greenhouse gas emission, air pollution, energy security, rising fuel price, and depletion of fossil fuel. So these are the main points why we need to convert from the fossil fuel to renewable energy. And the benefits, it will give us sustainability, because renewable energy is, from the definition, it is renewable, so it will not be depleted. It will be renewable by natural ecological cycles. And then indigenous resources, we do not need to depend on the other countries. We can generate our own resource. And then it will give cleaner environment. Then it will also create jobs, because as new technology will come, new system will come, and new job will be created, and it will give us finally the energy independence. So there are different means of renewable energy. Like as I told, like India has made rapid progress. We can see that how fast India is growing. But if we don't pay attention to our environment along with the development, then this development will be reversed. But the climate change may reverse our development gain in the recent decades. So India is already, it is estimated that India is already experiencing 1.1 degree of global warming, which is causing our extreme heat wave. So you can see that one part of our country is facing the extreme heat wave, whereas other part there are a lot of heavy rainfall, flood is happening. and in some places the catastrophic storms are coming. Earlier, if we imagine 10 years back, you might be showing that there are only 1 or 2 cyclones in a year. But nowadays, in a year, 5-6 cyclones are coming. So these are the basically adverse effect of this climate change due to this global warming. So it is estimated that India will lose its 2.6% of its GDP annually if the temperature rises to 2 degree instead of 1 degree to 2 degree. And it will loses 13.4% of GDP annually if the temperature rises to 3 degree. So as I told, like even though we develop, but our development will be reversed if we don't pay attention. So this will also increase our difference between the poor and rich people. So it is essential to develop renewable energy. Development of renewable energy could mitigate this projected cost and would also help to secure India's prosperity and competitiveness in the long term. Because renewable energy is more efficient, less polluting, producing immediate benefits such as cleaner air, greater energy security, and rapid job creation. So these are the renewable different type of renewable energy you all know, like solar energy, wind energy, hydro energy, biomass, geothermal, and ocean. So India is progressing very fast in solar energy. Then come to wind energy. Basically, wind energy is limited because you can only install this wind mills or wind turbines in the coastal region. You cannot install a wind turbine here. You can install it, but very small capacity, maybe 1 kilowatt, but not in megawatt level. So wind is limited, only in the coastal region you can install. Similarly, hydropower is also limited because we don't have these rivers or dams. These are also limited. So you don't have much scope in this. But biomass you have scope because in India a lot of biomass are available. But the main problem with the biomass is distributed in nature. You cannot get a source of biomass. Like if you want to install the 500 megawatt plant based on biomass in Durgapur, you will not get this available biomass because the volume of biomass is very less. So you need a huge quantity of biomass. So your cost will not be economic. So in case of biomass, if you want to go for, you have to go for the distributed energy generation. That means in kilowatt range in different places instead of a central megawatt plant like coal-fired plant. Then geothermal and ocean, these are very contribution is very limited, only 1% or something. So we have only the scope in solar, biomass. These are the main energy, renewable energy sources where you can grow very fast. So this is the global renewable energy scenario. What is the current global scenario? So who are the contributors to the renewable energy? You can say USA is contributing around 15%, and China is contributing 20%, and India is also not behind. India is also contributing a significant amount of renewable energy, that is 9%. Whereas total European Union, they are contributing 14%, and the South America, that is Brazil, basically is contributing 7%. These are the major contributors, but as other countries are also there, those are contributing 1%, 2%, it is written here. And if we go inside our renewable energy portfolio, then you see that among this total renewable energy, our solar is 57%, wind is 32%, small hydro is 3%, then waste to energy is 1%, and biomass cogeneration is 7%. Now let us see what is our target, what target our government has taken with respect to renewable energy or low carbon energy. So our Indian government in Conference of Parties, which was held in 2021 in Glasgow, United States, where our country, we have taken 5 nectar elements, 5 targets we have taken. So first target is to reach 500 gigawatt of non-fossil energy by 2030. So this was the first target we promised. Second target is 50% of its energy requirement should come from renewable energy by the end of 2030. And then reduce the total projected carbon emission by 1 million tons from now to 2030. And reduction of the carbon intensity of the economy by 45% at the end of 2030 with respect to 2005 level. What was there in 2005? We have promised that we will reduce it by 45%. And last but not the least, achieving the target of net zero emission by the end of 2070. But you see, the most of the developed countries, they have targeted it by 2050. But we are focusing at 2070. So basically, in India, we Indians are not so proactive. We are always reactive. When we see that others are doing, then we also start doing. So what was the harm if we targeted by 2050? Then at least our action plans was visible. But now as we have targeted 2070, now everyone is sleeping. So 2070 jab aayega dekha jayega. So this is the main problem, because India is growing, that is okay, India is developing, but we are not paying attention to our environment. We are not paying attention as it is required. Do you know one of our neighbor country who has already reached this net zero? They have declared that we have reached the net zero. Bhutan, yes. And what is the target of China? 60. Most of the European countries, developed countries, they have taken the target 50, but China has promised it but 60. Still 10 years before us. So we should have also promised like by 2060 we should. But it's unfortunate that we have taken the target 2070, but still to reach net zero by 2070, what are the things needs to be done? That is also not happening. So I don't expect that we will be able to reach it by 2070 also. So now coming to the different renewable energy systems, so I just explain it briefly. So solar energy I will explain it little bit more because we are working on solar energy, particularly solar cooking systems. And also I will explain it in detail about the biomass energy. But other energy I will just cover it, just give you some introduction. So solar energy is basically the radiant light and the heat from the sun, and it is harnessed using various technologies such as solar photovoltaic and solar thermal. So there are two ways of harnessing the solar energy. One is solar PV, another solar thermal. It is one of the cleanest and most abundant renewable energy source available, because sun is the source of the solar energy, so it is abundant. Now you can convert the sunlight directly into electricity using semiconductor material, that is PV panels, and commonly used materials like silicon, monocrystalline or polycrystalline. Nowadays polycrystallines are mostly used. And key component of a solar PV system is solar PV panel, inverter, charge controller, battery. Battery is optional, only for storing. If you want to store the battery, store it, then it is required. Otherwise, if you directly want to feed it to the grid, this is not required. But as soon as you add this battery, your cost will be double, almost double. And applications like rooftop system, solar farm, calculator, street lighting, and there are many more. Now this is the solar photovoltaic technology. This is the normal solar photovoltaic technology. So here sunlight falls in the solar PV panels, which generates the electricity in the form of DC. So this is extracted through a charge controller, and then it can be stored in the battery. Then from the battery you can convert it to AC, from the DC to AC through an inverter, and then you can use any appliances in your house. Or directly from here you can get it to the grid and from the grid you use it. So there are two ways of harvesting it in the form of from the PV panels. And then solar thermal routes. What happens in solar thermal? Use the solar energy to heat the water or air. And types: flat bed collector, evaporated tube collector, then concentrated collector or CSP, and applications: water heating, space heating, then industrial process heat, power generation, cooking, etc. Now this is the solar thermal technology. So basically, if you go to any hotels, specifically in the hilly regions, you will see that all these hotels, they are installed at the rooftop this type of solar water heater system. So there are solar panels, and through which these water tubes are connected. So the solar energy is directly heating the water. Then that water, hot water, is stored in an insulated tank, and then it is circulated to the rooms. So this is the conventional solar thermal based water heater system. So advantage: what are the advantage of solar energy? It is abundant and renewable, environment friendly, no greenhouse gas emissions, and you do not require any fuel. So once you install, you do not need any fuel every day like petrol, diesel or gas or whatever it is, or LPG. And it is low operation and maintenance cost. It is scalable from small rooftop system to the large solar farm, and it is suitable for the remote places. And what are the limitations? The major limitation with the solar energy, it is intermittent. So it is always fluctuating. It is fluctuating in the daytime, morning it is less, then at the afternoon it goes at the peak, then again decreases. Then also it fluctuates during the months. For example, now it is rainy days, last 1 month it is going on. So you will not get the much power from this solar panels, but still you can get 50% if you keep it well maintained. So energy storage need for off-grid use make it expensive, and efficiency affected by the weather and locations. So in the dusty weather, if you see, the efficiency of the solar panel decreases a lot. Now application of solar energy for cooking. So I will talk about the application of solar energy for cooking. So this is the solar cooking technology. Whenever we talk about solar cooking, one thing comes in our mind, that is solar thermal based cooking system. So what it happens, a major portion of the total energy is consumed by the cooking in our villages. If you go, you see that a family, what is the total energy consumption? You will see that among this, the majority of the energy is consumed by the cooking only. And half the world population burn wood or dried donkey to cook food. And in villages, 95% energy is consumed for cooking. So due to this burning of wood or dried dung, actually the people who are cooking, they are exposed to air pollution, lot of air pollution, and due to that, lot of diseases, air polluting diseases are happening. So the government of India has taken a lot of initiative to install solar cooking systems. So therefore, we need to harvest this solar energy and use it for the cooking. So conventional solar cooking principle, as I mentioned, like conventional solar cooking principle, solar cooker are passive solar devices. Sunlight is converted to heat energy, which is retained for the cooking. The step involved in solar cooker are the concentrating, capturing, and converting the solar energy. This is solar thermal route. So these are the different conventional solar thermal cooking technologies. So lot of this type of solar cooker you might have also done during your student life project. So like this is a solar panel type solar cooker. So cooking pot is enclosed by a panel or reflector. So there are reflectors, and at the center you need to keep your pot. So sunlight is reflected off multiple panels onto a pot and can reach a temperature up to 110 degrees. So you can only boil the water. You cannot cook means like frying and other applications which require high temperature. You cannot do it with this panel solar cooker. Then you have box type solar cooker. These are most common and easier to build and inexpensive. Still in many places like Rajasthan, Gujarat, and where the sunlight is very much available, there still box cooker are used in the villages. So it employs the greenhouse effect and it can reach up to 140 degrees centigrade. Then it comes to the parabolic solar cooker, where you have a parabolic reflector and you need to place the cooktop at the focal point. So with this you can reach high temperature, you can reach up to 450 degrees centigrade. So it focuses a lot of sun energy onto a very small space using a parabolic cell, and cooking pot is placed at the focus of the reflector. So by that you can get a higher temperature. But the major disadvantage of all these solar thermal based cooking systems are that you need to cook outdoor, cooking under the sun, outdoor cooking, which is not very convenient. Then cooking depends on sunlight, and also this process is very slow cooking process. So today people do not have the time. And you can cook only daytime when sun is available. You do not have any thermal storage in means built with this system, so you cannot use it in the night time. And another is long cooking time, and they do not have any heat control mechanism, so you cannot control the heat. When your sunlight is high, then you will get high temperature, but when you need high temperature, you cannot get it. So these are the main disadvantage. Why these technologies are developed long back, but still it is not popular. Then another technology that is for the community purpose, it is used, that is solar thermal collector based technology. So basically there are a lot of big solar collectors are installed, and then through this solar collector, basically that radiation is transferred to a solar receiver, and the steam is generated in this receiver. Then with this steam, either you can generate electricity, or you can store the steam and you can use it for the cooking. In India, there are a lot of this steam solar concentrator based steam generator used for different community kitchen. And also in Rajasthan, there are some power plant based on this technology. But as I told, like those technologies, solar thermal based cooking technologies are not convenient, and so it is not used by the people. So recently, instead of solar thermal, people thought like if we go for solar PV based cooking system, then it will be more convenient. A person can cook inside the kitchen like what they use, like electric heater or induction heater or LPG. Similarly, they can cook it if they use through this route. So here basically you have a solar panel, and then through this you get the electricity and then convert it to the DC to AC, and then you can run induction or resistive heating system. And also it is, when it is not in use, you can store it in a battery. So solar energy is converted into electricity using a solar PV panels, and a charge controller regulates the power flow to ensure optimum energy harvesting based on the connected load, and surplus energy is stored in a battery for the use during the night or when sunlight is not available. So advantages, as I already told, like advantages are simple and compact structure. You can do all type of cooking, boiling, steaming, frying, everything you can do, and no fuel requirement, fast and uniform heating, and you can use it inside the kitchen. Then cooking during the day and night, anytime you can do. Then you can also have a temperature control, and cooking is similar to the conventional cooking system. So that is what this technology, this advanced solar cooking technology is now gaining the popularity in India. So different institutes, they have worked on this, like IIT Bombay, they have developed a similar technology, that is solar advanced solar cooking technology, which is, they have named it like SOULS. This is developed by the team of IIT Bombay, and they are, as a pilot project, they have installed a number of such systems in a village like Bancha, it is located in MP. So this pilot plant study is already done, and they have also transferred this technology to different industries for commercializations. Similarly, very recently the IOCL, Indian Oil Corporation, they have developed a technology for the advanced solar cooking technology. Here also similar principle is used, but for the storage, instead of battery, they have used the thermal storage. That they call this the thermal battery. This also become very popular nowadays. This is the name of this technology is called Surya Nutan. Then at CSIR-CMERI also we are working on this, and one of our students team, they have developed, first they developed one prototype using the available components. So basically this is the very simple thing. So you have solar panel, charge controller, battery, inverter, and then you convert it from AC to DC and then run it either resistive or inductive current. And we have installed in our guest house, CMERI guest house. But the major drawback of this technology is the battery. This is the only weakest point, because the life of this battery is less. Because solar panel has the life of 20 to 25 years, but you need to replace this battery maximum 3 years to 4 years. After that, you have to replace it. That is the only drawback. So if you can replace this battery with some other storage technology, then it will be a game changer. And also battery, as you know, like battery is not a very environment friendly. So recycling of battery is another problem. So first it was like AC base. So you have like charge controller, then you have inverter to convert it, and then store it battery, then use it. So first we thought like how to reduce it. So in the second project, what we do, we replace this inverter and we develop a direct DC based cooking technology. So this is our DC based solar cooking technology, and the select point is DC based cooking system without inverter, simple and compact, and heat control, fast and uniform heating. All type of cooking can be done, day and night you can cook it, and no fuel requirement. And this is insulated cook stove, so it reduces the heat loss, and it provides cleanest environmental pollution. So you cannot get any pollution. Even if you use LPG, you don't know, you cannot see, but you are generating CO2, and that you are inhaling. But if you go for solar, there is no CO2 also. So you can save around 1 ton of CO2 per year if you use one such domestic system. So we have developed this technology. We have also transferred this technology to these two parties, and we have also patented. And also we have installed in different places as a demonstration. And presently we are working to replace this thing, battery, inverter, and this thing with a solar thermal energy storage based system. So this is the current work we are going on. This project is funded by GAIL India Limited. So our objective is to reduce these three components so that the cost will be reduced and also it will be more environment friendly. So we are using basically thermal energy storage system. So you know that there are different type of thermal energy storage system. One is latent heat storage system and another is sensible heat storage system. So we are using the latent heat storage material, that is PCM material, that is called test change materials. So instead of battery, we will be storing the heat in the form of thermal energy, that is heat as a heat we will store instead of electricity. So that directly whenever heat is required, we can use it, and whenever it is not required, it will be stored in the PCM material. So as I told, like benefit will be environment friendly, it will be cost effective, longer life, and it will reduce the dependency on the battery. So then coming to the wind energy, as I told, like wind energy is a quite mature technology. There is not much scope, but there are only scope in the material side, because till date in India we import this wind turbine. We are not developing our wind turbine. So like wind energy is the kinetic energy of moving air masses. Wind turbine convert this kinetic energy into the mechanical, and then from the mechanical to electrical energy. It is one of the fastest growing renewable energy sources worldwide. So this is the principle how it works. So basically we have blades. So wind is coming and the blade is rotated. Then at the back side you have a generator. So it is generating the mechanical energy. then through the generator we are converting it to the electrical energy. So wind, then rotor blades, mechanical rotor, the generator, then electricity. The applications: grid electricity, water pumping, and hybrid system. So these are the applications generally used for the wind energy. So if you go to any coastal like in Kerala, you will see lot of wind turbines are installed, but many of these are not working. Then there are two types of wind turbines. One is horizontal axis wind turbine, another is vertical axis wind turbine. So in horizontal axis is the most commonly used. Rotor shaft is horizontal and parallel to the ground, whereas in vertical, the rotor shaft is vertical, can operate in any wind directions, and less common and suitable for urban areas. Then advantage and disadvantage. So advantage, like it is a very mature technology, so you can immediately install it. This is clean and renewable, low operating cost, and scalable for small to large farm. But the limitations, again the limitation is intermittent. Whenever you have wind, that time only you can generate the power. You cannot get it whenever you need. And also it is site specific. You can install it in the coastal region only, and it gets lot of noise. So you cannot install even, there is a possibility also you cannot install in the locality. So you have to install in a remote places. And also there is a problem with the bird pollution. Big blades are there, so always it is collide with the birds. So a lot of birds they get injured. Then coming to hydro energy. So as you know, like hydro energy, so water is stored in the dam. So only if you have a dam, then only you can generate the hydro energy. And the potential energy of this water, which is kept at a higher altitude, that potential energy is converted to the kinetic energy, and that kinetic energy is used to run a turbine to generate the electricity. So like you see, this is the reservoir. Through this the water comes. Then there are Pelton turbines which are rotated and it generates. We have one hydro turbine in Maithon. Maithon we have basically two hydro turbines, but very small capacity, 20 kilowatt. So types like large hydro, small hydro, micro hydro, pump storage. Pump storage, there are one pump storage at Purulia. So basically what happens there, you do not have a natural source or dam. So whenever there is a excess electricity, what is pumped to a higher altitude, and when it is required, power is required, that time it is used. So advantage, it is reliable, high efficiency, greater than 90%, long life, but limitations, the high capital cost and ecological impact, because you cannot create dams in anywhere. You need water also for agriculture purpose, and rehabilitation issues. So these are the limitations of this hydro energy. So now to understand this solar, then hydro, then wind, so let us see some simple example. I will give you some problem. So let us see how we can do it. So a simple problem, suppose a solar panel has an area of 2 meters square and a conversion efficiency of 80%, 18%. If the solar radiation is 1000 watt per meter square, calculate the electrical power and also calculate total energy generated in a day if the solar panel receives sunlight for 6 hours a day. Can you do it? It's very simple. So do you know the solar PV panel you have seen now? So what is the area, do you know? What is the width and what is the length and what is the capacity? Any idea? Anyone can tell, guess? 2 meter by 1 meter. And capacity? Any idea? Any guess? Earlier it was like 250 watt was the standard, but nowadays it has improved it is increasing very fast. Now you can get even 600 watt per panel. So if you installed it 5 years back, then in the same place you can get it double. So you would like to try it? So very simple. So the irradiation is given this watt per meter square, and you have the area 2 meter square. So 2000 and multiplied by 0.18, so 360 watt, and then this 6 hour a day, adding then into 6. So basically, the thumb rule is that in a sunny day, it can generate only if your capacity, suppose one solar panel capacity is 500 watt. In a sunny day, it can generate 500 into 4, only 2 kilowatt in the 12 hour. So this is the thumb rule. And rainy days it will be much less than 50%. So his answer is 360 watt and 2.16 kilowatt hour. Next, this one you should do it. So a solar electric cooker, suppose you have installed a solar electric cooker of 1 kilowatt capacity, and you operate it 3 hours per day for cooking 3 times or 4 times in a day, total 3 hours, and you require a battery backup of 4 hours because anytime in the night time you want to cook it. So by considering the average peak sun hour 5 hours per day and overall system efficiency 80%, and the depth of discharge of the battery, if you take it 80%, then calculate the required solar PV panel capacity and required battery capacity. So all of you are from mechanical or electrical also?
From diverse.
So if you are from electrical, you can easily calculate it. So from mechanical, little bit difficulties you may find. Anyone tell me just how to process? कैसे करेंगे इसको? कैसे कैलकुलेट करेंगे? हमको ऐसा करना है तो कितना हमको बैटरी लगेगा वो तो जानना पड़ेगा ना, कितना हमको बैटरी लगेगा, कितना हमको सोलर पैनल इंस्टॉल करना पड़ेगा. So your capacity, cooker capacity 1 kilowatt, you are running it 3 hours. So you need 3 into 1, 3 kilowatt hour, 3 unit. You need 3 unit. And you need 3 unit for 5 hours. Solar panel, the average peak sun hour is 5 hours. So 3 divided by 5 will be your solar panel capacity required. 3 kilowatt divided by 5 is 750 watt. So 750 watt peak solar panel if you install, then you can easily do this. You can install a 1 kilowatt capacity cooker and you can run it for 3 hours. Then you need backup, 4 hour backup. So how much you require? 4 kilowatt hour. You need to store 4 kilowatt hour. And your system efficiency, here I forgot to calculate the system efficiency, so you have to divide it into 0.8. So then for this battery backup, so you need 4 hours, so you need 4 kilowatt hour, and you need 4 kilowatt hour. So suppose if you install 12 volt battery, so how many batteries will be required, and what will be the ampere hour for each battery? So if you calculate, you will see that you need 48 volt, that means you can install 4 12 volt batteries in series, and the ampere hour is this, so you can select little bit more, you can go for 150 ampere hour battery. So you need 4 12 volt batteries. So why I have given this example, because I want to realize that what is the requirement, so you can understand what is the cost involved. So what is the main drawback, that this renewable energy is popular, but still it is not so popular among the common people? That is because the upfront cost is very high. So whenever a common people, it comes to me, suppose I will not be purchase one solar cooker. Why? Because I need to pay this much amount, 50-60,000, initially. I will not be interested. Though I will get return on investment within maybe 4 hours, like 4 years or 3 years, but still I will not be able to invest initially so much. So that is the only drawbacks of the renewable energy. If you go for renewable energy, always cost will be high, but the government has to come from. So they have to give the advantage to the users. Like you are using solar energy, so you are saving CO2. So if government gives some incentive, like you are saving 1 ton per year, so for that government gives some extra money, and also government gives a subsidy for the solar panels. Government gives a subsidy for the solar panels, but not for cooking application. If you install a solar panel at your rooftop and if you connect it to the grid, then there is a scheme for the subsidies. So these are the factors. There are a lot of factors why renewable energy is not to be so popular. But if you go to any developed countries, you will see there are a lot of incentive regimes. For example, I can give you example in most of the European institute, what they do, suppose you are coming to your office by car or bike, then you are consuming your fuel, petrol or diesel. Instead of that, if you come by cycle, they gives you 0.25 euro per kilometer. So I see that in the morning everyone is coming to the cycle. So every student also coming to the cycle. So very less people who are staying very far, they are only coming, and that too they are coming by train, not by personal car. So this type of incentive is also, this type of awareness is also required from the government. Then only this renewable energy will be popular in our country. Otherwise we will talk, but nothing will happen. No significant things will happen. It is happening, whatever is obvious that will happen, but we have to go fast. Similarly, calculation you can do it for the wind turbine. Suppose a wind turbine has a rotor diameter of 6 meter and operate with the average velocity of 10 meter per second. The density of air is given and the efficiency of turbine 35%. Calculate the power output. So tell me, this is a very simple calculation, class 12. So how will you calculate? Velocity of air is given, your diameter is given. So first you have to find out the kinetic energy, half mv square. What is m? M is the amount of air that is rotating the blade. So that is giving the kinetic energy, no? So density is given, from that you can calculate the volume of the air, and velocity is given, area is given, diameter means area is given. So if you multiply area into volume, then you will get the area into velocity, you will get the volume flow rate. You multiply it with the density, you will get the mass, then half mv square kinetic energy, and then divide it with the efficiency, then you will get it. So this will be 6.05 kilowatt. Then a same problem for the hydro. A micro hydro power plant has a flow rate of 0.2 meter cube per second and a head of 12 meter. If the overall system efficiency is 75%, calculate the power output. So I am not going through the details. So this will be like 1.77 kilowatt. Now we will come to the energy from biomass, because biomass, energy from biomass is one of my main research area. So I did my PhD on energy from biomass. So I will explain it more in details. So up to this, do you have any questions? Or if you have anything, you can ask it or discuss it. Okay. So can I sit here? So biomass, biomass has a distinct advantage over the use of other renewable energy sources like solar. The main disadvantage of solar, as I told, solar wind is the intermittent. But biomass, whatever biomass you need, you can generate the power anytime. So this is the advantages. And biomass does not add any net CO2. Why? Because when we grow the biomass, same amount of CO2 is absorbed by the plants. So it is a carbon neutral. And sulfur content in biomass is low, very low compared to coal. And as you consume biomass, so you need to plant it more. So the restoration of degraded land as a result of plantation and possibility of increase in the biodiversity. And biomass is abundantly available and cost effective source. Like we are mainly rice producing countries. In eastern region we produce lot of rice. So when we are producing rice, with the rice we are producing the rice husks as a waste. So this can be easily used to generate the energy. So there are different routes of converting biomass, like one is thermochemical conversion route, one is biochemical conversion and mechanical conversion. In thermochemical, then there are also three different ways. One is conversion, gasification, pyrolysis. Then biochemical, you have fermentation or digestion, and mechanical conversion is mechanical. So basically through oil press, that wild seeds are compressed and converted into oil, and then through transterification process you convert it to biofuel. And thermochemical conversion, there are like three routes. One is combustion, gasification, pyrolysis. Do you know what is combustion, gasification, pyrolysis, and what is the difference? Combustion, you know, like any coal-based thermal power plant, we burn the coal. Similarly, we can combust or you can burn the biomass, same way. The difference between combustion and gasification and pyrolysis is that in pyrolysis, this is also thermal process, heating process, but here it is done with the absence of air, any oxygen. And gasification is done with partial air, not with the complete combustion. So basically here, when you will go for the combustion, you will generate a flue gas, through which you generate the steam. But in gasification and pyrolysis, instead of flue gas, you will generate the fuel gas, which will contain a mixture of methane, carbon monoxide, a part of CO2, hydrogen, a mixture gas. So with that mixture gas, you can run a gas turbine and then you can generate electricity, or you can burn it to produce heat. So as per requirement, or also you can use it as a precursor for different chemicals productions. Similarly, biochemical process, like through fermentation and digestion. Through fermentation you convert it to ethanol, and through digestion, anaerobic digestion, you generate biogas, and from there you can use it as a transportation fuel, you can use it as a chemical, you can use it as a heat, you can use it for the electricity generation. So these are the different routes of converting biomass into energy. Now, first I will come to the biomass combustion. Basically, biomass combustion means co-firing. As I told, like biomass, the nature is that it is distributed in nature. So you cannot have a big power plant. Either you should have a distributed power generation, or what you can do, the easiest way is that you can co-fire the biomass, some amount of biomass, with the existing coal-fired plant. So this is the easiest way to increase your biomass consumption and reduce the pollution. So that is called co-firing. So co-firing of biomass to the existing coal power plant. So the co-firing is the process of burning two different types of fuel simultaneously to generate heat or electricity. There are many advantages of co-firing of biomass with coal. Like co-firing is the easiest way to increase the use of biomass for the power generation. It requires little modification to the existing coal plant. Just you can retrofit it with the existing system. So you need little modifications. It will provide the opportunity of using different biomass material with the coal, and it will result in lower CO2 emission by saving the fossil fuel. It will reduce other emission also, as I told, like if biomass contains lower amount of sulfur, so it will reduce the SOx. Also, when you will use the biomass, the temperature will reduce, so your NOx formation will also reduce. And and it provides the energy security to the nations by producing electricity from locally available fuel. Like coal, still we have coal, but still we import lot of coal because we do not have a good quality coal. So we sometimes import the anthracite coal from other countries. So instead of importing, if we replace biomass with, then we can reduce the fossil fuel as well as we can also reduce the dependency on the other countries. So co-firing, there can be different type of co-firing. This is called direct co-firing. So suppose this is your coal-fired power plant. So what you do in the furnace, your coal is going. With the coal, you introduce some amount of biomass. So this is called direct co-firing. Directly you are introducing your biomass with the furnace, and then other process is same. Then you generate the steam, then you run the turbine and generate the power. And in India, still only the direct co-firing is only used. Then indirect co-firing, what happens? Before co-firing, instead of co-firing biomass directly into the furnace, you generate a gas through a gasifier. So in a gasifier, you convert the biomass into a fuel gas. Then instead of directly using the biomass, you use that gas, fuel gas in the furnace, and then rest of the things are same. This is called indirect co-firing. And then there are parallel co-firing. Like you will have two different boilers. In one boiler is for the coal, another boiler is for the biomass. And then the steam what is generated, that both the steam you add it, and then that you use it for the running the turbine, and the other system will remain same. So this is parallel co-firing. But in India we do not have any indirect or parallel co-firing. We only have some, in some plants we have started direct co-firing. So this is a co-firing of biomass. I can show you a video. So where NTPC is using it. Can I play this video? Your mouse or something? Video down touching. ওটা একবার এসকেপ করে দেখুন না, এটাতে ক্লিক করলে আসার কথা।
ভিডিওটা চালু।
So this is a NTPC thermal power plant where they started using biomass along with the coal. So this is direct co-firing.
India is an agricultural country. According to estimates, agriculture employs more than 50% of India's workforce, and it is the primary source of livelihood for majority of population in India. With the rise in crop produce, farmers have another menace to deal with, which accompanies the production of crops, and it is none other than the crop residue or the agro waste. The paddy crop is usually harvested between the first and last weeks of October. When paddy is harvested with only 10 to 15 days left between the rice harvesting season and the wheat sowing time, farmers find burning the stubble to be the most easy, quick, and economical way to eliminate the paddy straw. Crop residue burning gives rise to huge clouds of smoke, which has adverse impact on environment in northern India. Open crop residue burning continues on a massive scale. The only way to prevent this crisis was to incentivize agro waste and generate a market force to consume its huge quantity. The agro waste is collected, stored, dried, and afterwards processed into biopellets in separate units, which is then used for power generation in coal-fired power plant. And India's biggest power producer, NTPC Limited, realized the power potential of these biomass pellets and has since created a huge market force. NTPC has issued a tender to procure 20 million metric tons biomass pellets over a period of 4 years. That is 5 million metric tons on annual basis. The quantum of biomass which the NTPC envisages to use per annum has a potential to generate 1,000 megawatts biomass unloading mode. The details of truck, the biopellet seller are noted down. The next step is the collection of samples from the truck top. The official personnel land on truck top after climbing the ladder placed safely near the truck top. The personnel remove the top 25 centimeter layer of biopellets. And then collect samples from 4 to 5 random spots. These samples are tagged and then taken to the chemistry lab. In the lab, the samples are thoroughly mixed.
This is a standard test mechanism as per ISO standard we have to do.
They are further reduced by coating and quartering method till the samples are worth 4 kgs in weight. The sample is then divided into 4 equal parts of 1 kg each. 1 part is for seller, 1 for FD, 1 for NTPC, and 1 for fines. All of the samples are packaged and tagged.
So first they do the analysis. Based on the analysis, actually price of the pellets are decided.
The personnel then take sample worth 100 grams and crush it for a definite period of time in a mortar vessel. The crushed sample is also put through 1 millimeter and 3 millimeter sieve dispenser. The quantity put through the sieves is also reported in percentage. Parallelly, the sample is also tested for total moisture. This whole process in the chemical lab lasts for at least
So first they measure the
1
moisture. How much is the
If the
moisture?
sample meets the NTPC's technical specifications, then the sample of biopellets is cleared for unloading. If it does not, then the sample of biopellet is rejected. The sample is also tested for gross
This
calorific
is
value
GCD
(GC)
measurement. This is
and
called boom
belongs in a
calorimeter.
separate test. After getting the go-ahead from the chemistry lab, the truckload of biopellets gets weighed and unloading of biopellets begins soon after. Unloading is done very carefully, maintaining all the safety standards. After unloading, a bulldozer pushes the biopellets into reclaim hoppers. The NTPC personnel rotate the operating wheel and push the pellets from the hoppers through the mechanical bi-flow feeder onto a conveyor belt in a fixed quantity.
So this is directly
The
mixing
conveyor
with the
belt
coal.
carries the pellets
So
ahead.
one side biomass
The
is
coal
coming,
gets
another side
added
coal
to
will
the
come.
conveyor belt from a separate hopper.
Separate
The
coal. Then
conveyor
it is
belt
mixed with the
containing
coal.
the coal and the pellets reaches the bunker from where it is fed into the mill. The mill is where both the pellets and coal are thoroughly pulverized mixed. This pulverized mixture goes into the furnace which is
The
used to
furnace.
generate electricity. This entire process is called biomass profiling. It has been hailed by the United Nations Framework Convention on Climate Change, UNFCCC, as a technology which helps mitigate greenhouse gas emissions. UNFCCC recognizes biomass profiling as a carbon neutral technology for mitigation of carbon emission from coal-based power plants. Biomass profiling makes a better alternative. If the paddy stubble isn't processed into pellets and directly torched, then it
So now Government of India told the NTPC that you have to co-fire 5 to 10% of biomass in every power plant. But what happened in reality, when NTPC started working and they started to implement it in 2-3 plants, then they are not getting the pellets because our biomass is available, but our market is not so well established. So suddenly there is a crisis. So then they need to stop. So only they are introducing it only in few plants. So there is no initiative from the government to make it more popularized. So these are the reality actually.
Biomass is also polluting.
Biomass is no, it is going to the coal, na?
But carbon, you also produce carbon dioxide.
But when your plant is growing, same amount of carbon dioxide is already stored. So it is neutral basically. So when you are burning it, it is releasing the same amount of CO2. So if you take a life cycle analysis, it will be 0. So that is what biomass is clean. So biomass gasification, as I told, like gasification and combustion difference is that in case of combustion you use the sufficient amount of air to burn it to convert it to the flue gas, whereas in gasification you use the limited amount of air so that you do not allow to burn it completely. Instead of that, you generate a fuel gas, so which contains hydrogen, CO, CO2, methane, H2O and nitrogen, because as you are using air as the gasifying agent, you can get nitrogen, but if you use steam, then you will get more hydrogen and you will not get nitrogen. So these are the reactions. So in gasification, basically there are different type of gasifier technology: fixed bed gasifier, fluidized bed gasifier. Fixed bed gasifier also there are different type of like updraft, downdraft, crossdraft. So I am not going through the details. So these are fixed bed biomass gasification plant which is installed in our CMERI campus. So this is basically the capacity is 10 kilowatt, and you can use different type of biomass. You can use pellets, you can use raw biomass, wood chips, then rice husk. So basically this black one is the gasifier, this is the downdraft gasifier, and the gas which is produced, this is coming through different filters. So there are dry filter, wet filters, and then that gas, clean gas is introduced to a gas engine to generate the electricity. And around 10 kilowatt is the net generation. Basically the total generation, some of the amount which will be consumed by this cooling tower, and also there are some motors, bimetric motors. So around you can get 7 kilowatt as a net generation, and biomass consumption rate is 10 to 15 kg per kilowatt hour. So there is the, at the top you have the hopper, so you need to open this and you have to introduce the biomass from this side. And this is a 100% producer gas based engine, so directly it runs with this gas and it can continuously run it and generate the electricity. So this is the generator. Then fluidized bed gasifier is the main advantage of fluidized bed gasifier is that it is more efficient, because what is fluidization? Basically, suppose you have a particle, bed of particle, and if you air or some liquid, some gas at the bottom, then after some time what will happen, these particles will be just floating on the gas. So that is called fluidized bed. So in fluidized bed, basically you have a more intense contact between the gas and particle. So the conversion efficiency, heat and mass transfer rate is very high. And there are different type of gasifiers: bubbling fluidized bed gasifier, then circulating fluidized bed gasifier. In bubbling fluidized gasifier, what happens? You introduce the air at the bottom, and the particles are just go up and then come down, go up and come down. Whereas in circulating, it will go up, then it will enter to a cyclone separator, and the particle will be separated and come back to the bed again, and gas will go out. So advantage of fluidized bed gasifier, as I told, like intense mixing of solid throughout the reactor leads to very nearly isothermal operations. And fuel flexibility, you can use any type of biomass fuel with this fluidized bed system, and it is suitable to moderate to large scale. Like in fixed bed, you can go maximum up to in kilowatt range, 50 kilowatt, 100 kilowatt, but in fluidized bed gasifier you can go up to megawatt range. And transportation of the heat between the two fluidized bed reactor is possible through the circulation of solid, and it is having a high heat and mass transfer rate between gas and solid particles compared to the other mode of operation. Now there are different applications of fluidized bed system actually. Other than gasification, you can use also like heat exchange, drying, coating, galvanization, and gas purification, like fluid catalytic cracking, then synthesis of reactions, then polymerization, silicon production, pressure tube applications, then fluid cracking and flexi coking, coal biomass waste combustion, coal biomass gasification, etc. So these are the different biomass gasification technologies or setup, experimental setup we have. Like these are benchtop bubbling fluidized bed setup. There you can do different type of experiment. You can study wall to bed heat transfer, and fluidization velocity you can calculate, and by changing the material, by changing the gas flow rate, by changing the height, you can do lot of experiment. Then this one I have told already, like this is a pilot scale fixed bed gasifier, this is a bubbling fluid gasifier, then this is a bubbling fluid bed hot model. Basically it is the actual hot model where you need to introduce the biomass from this, and this system, actually this type of reactor is placed inside a electric heater, because gasification is endothermic reaction, so you need to provide heat from the outside, whereas combustion is exothermic, so you do not need to provide the heat. So due to this gasification process, the gas is generated. So these are the some experimental result of the gas composition you can see. So if you vary the temperature, if you vary the equivalence ratio or gas composition, everything will vary. So the gas composition we use to collect it, and then we have gas chromatography for the analysis of the gas. Then this is a circulating fluidized bed. So the principle I have showed, like this is a small, means as a long riser through which particles are go up, and then there are cycle separators through which particles get separated, gases go out from this. So we collect the gas from here and we analyze it. Now just if you have some interest, then I can tell about this CFD modeling. So any one of you work on CFD modeling, computational fluid modeling, otherwise we can skip it. So basically this fluidized bed system is a multi phase system. Like in CFD, just I will give a brief introduction, then I will skip rest of the thing. So like in CFD modeling, there can be a single phase modeling or multi phase modeling. In single phase, you can have either Eulerian approach or Lagrangian approach. Suppose if you want to model particle, only particles, then you have to go for Lagrangian. If you want to model for the gas, that is any gas or liquid, then you have to go for Eulerian approach. Whereas in multi-phase system, you will have both gas as well as solid. Like in fluidized bed, you have both gas as well as solid. So there you can go, you can select two approach, either Euler-Euler or Euler-Lagrange. So in Euler-Lagrange also you can have a unidirectional or bidirectional. So I am just skipping those slides. Modeling, detailed modeling. Then when we talk about renewable energy, and if we don't mention two things in today's parlance, one is hydrogen energy and CO2 capture, then it is incomplete. So our next energy is the hydrogen energy. Why? You have already heard about many lectures about the hydrogen energy. So what is the advantage of hydrogen energy compared to conventional energy? Can you tell anyone? What are the advantages of hydrogen energy? Why less pollution? So hydrogen is only having H2. So if you do combustion, it will produce only H2O. There is no carbon. So there is no chance of CO, CO2, anything. So that is the main advantage. And also hydrogen energy density is very high per kg of hydrogen. So basically, when we talk about hydrogen energy, there are three areas the work is going on. One is hydrogen generation, another is hydrogen storage and transportation, another is hydrogen conversion. So CSIR-CMERI is working in all these three areas, but I will not discuss in detail because it will take another lecture. So I will just briefly I will tell you what we are doing. Now based on the generation, actually hydrogen can be classified in different ways, like black hydrogen or brown hydrogen. So if you generate hydrogen from the coal, fossil fuel, through gasification, which is the mostly used nowadays, that is called black or brown hydrogen. Then grey hydrogen, if you produce the same steam reforming for the natural gas you do, then you will get the grey hydrogen. So these two are basically highly environmental polluting. So it is not a very environment friendly, because you are generating it from fossil fuel. So basically you are just converting one energy to another energy. So first you need to get, means you are using coal, one disadvantage. Another is you are doing gasification. So basically you are doing the pollution. And then natural gas, you are first getting the natural gas, instead of directly using it, you are converting it to hydrogen. So So then there are some conversion losses. So that is what these two methods, though at present we are generating about 96% of hydrogen through this process, but we have to replace it with the green process like this. So like blue hydrogen, what is blue hydrogen? Same process, but if you install a CO2 capture unit with this and you capture the CO2 from the process, then it will become blue, more environment friendly. Then Turkish hydrogen, that is if you use natural gas and from that through pyrolysis process it will generate hydrogen, that is Turkish. Then yellow, so most common of hydrogen generation is the water electrolysis. This is the next generation technology, but the main disadvantage is still cost is not competitive, cost is very high. So if you use water for electrolysis and generate hydrogen, and if you use your grid power, then it is called yellow, because this grid power which is coming from your coal fire power plant mostly. So this is yellow. And then water and electricity from nuclear source. Electricity nuclear source, you use electricity nuclear source and water as the your basic element for converting hydrogen, means generating hydrogen through electrolysis. This is called pink and red. But finally you have to come here. So water electrolysis, and then use renewable energy, use solar energy. Then it will become green. Or use biomass and the power electricity used from solar, then it will become green. So we are working in the generation, basically we are working in this both through water electrolysis as well as from biomass. So I am working from the biomass to hydrogen generation, whereas another group in CMERI they are working through water electrolysis. So this is the process how we are generating. Basically this is called two-stage pyrolysis reforming process, and we are using low-cost catalyst for enriching the hydrogen as well as to capture the CO2. And then that CO2 what we are capturing, that we are converting to valuable product. So we are converting it to valuable product so that we can directly use it. So combinedly this will be a green hydrogen production mechanism. So then like one of our group are working on hydrogen storage. Like we are working on the hydrogen storage for type 4 tank. So as you know, like in type 4 tank you have to store the hydrogen at 750 bar. So earlier we have already developed for type 3, that is 350 bar, and now we are working on the storage of 750 bar. But there are different other method of storage, so that we are not working. So like metal hydrate, etc. And next is the hydrogen consumption, like hydrogen, use of hydrogen. So use of hydrogen you can do in two ways. Either you use hydrogen for fuel cell and then transportation application you can go, or you can directly run a IC engine with hydrogen ICs. So we have two groups. One groups are working on hydrogen fuel cell based EVs, electric vehicle, and another group is working on the development of direct injection hydrogen IC engine. Now as I told, like this lecture will be incompleted if we don't talk about the carbon capture. So carbon capture, basically carbon capture, utilization and storage, this is the complete process, but most of the cases we only do the capture, but only capturing the carbon is not meaningful. Suppose you capture it, then what will you do? So many people are doing to just show that they are doing something, they are capturing it and again they are releasing it. Some gas is going, from there they are capturing, they are bottling it and then they are releasing it. So either you have to utilize it, but utilization portion is very less. How much carbon you can utilize? Because you can understand how much CO2 is generated in our coal fire power plant, our coal plant, our steel plant, our cement plant. They are the major producer of CO2. So you cannot utilize. You can utilize only a portion, maybe 1%, 2% you can utilize as a chemical. So you need to store. But in India, still very few people are working in the carbon storage, that is underground carbon storage. Only IIT Bombay they are working. So there is a huge scope in this area, but this requires big area and big setups. So So basically, suppose this is the source, any power plant, you need to capture it, and then you need to compress this CO2 and then transport it. Then either you go to any chemical plant for utilizing the CO2 for producing any chemicals, or you need to store it in the underground. Like CBM. In CBM, what happens? Coal bed methane, one side CO2 is purged, another side methane is released. So CO2 is entrapped inside the ground. So you can capture the CO2 as well as you can extract the methane. So thank you. With this, I end my talk. So if you have any queries or anything you want to know more about the projects or anything about the work or any R&D work you want to do with the CMERI, you are most welcome. So thank you very much. So this is my last slide actually. Chala gaya. Last slide, just give me this slide. I kept up one picture. So the end. Don't they put another last slide? So I used to end my lecture generally with this photo. So like you can see, this was our yesterday and this is our today. So it's already melted, and if you don't pay attention, this will be your tomorrow. But we should not allow it to keep going. So we'll stop it and we'll try to come back to here. So that will be our next aim or motto. So that is what we need to convert to the renewable energy. So thank you all.
Thank you very much, Dr. Loha, for a wonderful deliberation. Now it's time for a tea break, and after that we will meet for a session where we will just collect the article summary, and that will be the end of today's session. Thank you very much. Thank you once again. Group A, B, members from Group A, B as well as I, they have not yet submitted the article summary.